In the summer of 2017, a young archaeologist named Matthew Stewart was walking across a stretch of cracked, pale ground in the western Nefud desert of northern Saudi Arabia, deep in the middle of his own PhD fieldwork, when he noticed something odd underfoot. The wind had spent months, maybe years, stripping away the loose sand that normally buried this patch of the desert, and what it had exposed wasn't ordinary rock or dune. It was the hardened floor of a lake that hadn't held a drop of water in over 100,000 years, and pressed into its surface, preserved as if someone had walked across wet concrete and simply never come back to smooth it over, were shapes that didn't belong to wind or erosion at all. They belonged to feet. Some were enormous, wide, three-toed impressions that could only have come from something the size of an elephant. Others were narrower, cloven, unmistakably left by camels, and scattered among them, easy to miss if you weren't looking closely, were smaller, more familiar. Shapes, ones that looked disturbingly like the print your own foot would leave if you stepped barefoot into soft mud. Stewart had stumbled onto what would later be named Alathar, an Arabic word that simply means the trace, and it would take 3 more years of careful excavation, laboratory dating, and painstaking comparison before the full weight of what he'd found underfoot that day became clear. Those small, human-shaped impressions weren't just old, they were roughly 120,000 years old, and they were about to force paleoanthropologists to rewrite a chapter of the human story that most of them thought had already been settled. To understand why a handful of footprints pressed into ancient mud mattered so much, you first have to understand what the Nefud Desert actually is today, and what almost nobody thought it could have been in the deep past. The Nefud is one of the harshest, most unforgiving landscapes on the planet, a sea of towering red sand dunes roughly the size of the state of Kentucky. Sitting in the northern interior of the Arabian Peninsula between Jordan and the heart of Saudi Arabia, summer temperatures there regularly climb past 120 degrees Fahrenheit. Freshwater is essentially non-existent, and for most of the 20th century, the scientific consensus treated the entire Arabian interior as functionally irrelevant to the story of human evolution, a vast, empty barrier that early humans would have had every reason to avoid rather than cross. The textbook version of the Out of Africa story, the one most people who ever took an introductory anthropology course would recognize, involved modern humans slipping out of Easto. Africa along the southern coastline, hugging the shores of the Red Sea and the Arabian Sea, sticking to fish, shellfish, and fresh water, wherever they could find it, and deliberately steering clear of the deep, dry interior. Arabia, in this version of events, was scenery you passed by on your way to somewhere else. It was not a place people actually lived. That assumption started cracking years before. Stewart ever set foot in the Nefud, largely thanks to the work of an archaeologist named Michael Petraglia, who had spent the better part of a decade running what eventually became known as the Green Arabia Project, later folded into research efforts called Paleodeserts and Disperse. Petraglia's team had a genuinely clever idea. Rather than wandering the desert hoping to stumble across something interesting, they pored over satellite imagery of the Arabian interior, hunting for faint, ghostly discolorations in the sand that might mark the buried remnants of ancient lake beds. As Petraglia's colleague Hugh Graucut later described the process, they eventually identified an almost absurd number of candidate sites, and in the years that followed, ground surveys confirmed that vast stretches of what is now bone-dry desert had, at various points over the last several 100,000 years, been something closer to the African savanna. At certain windows in Earth's climate history, the monsoon systems that normally soak east, Africa and India shifted north, dragging seasonal rains deep into the Arabian interior. Rivers ran, lakes filled the low hollows. Between the dunes, grasslands spread across what is now barren sand, and with them came the animals that depend on grasslands and fresh water to survive. One of the sites that came out of this satellite hunt was a place called Kal Ameshan 4, tucked into a gap between towering dunes in the Nefud, and when Petraglia's team dug into its layered sediments, they found something remarkable. Buried in bands representing 5 separate wet phases stretching back roughly 400,000 years, they recovered thousands of stone tools, each layer showing a distinct style of tool-making, suggesting that different populations, quite possibly different species of ancient human relatives entirely, had moved into the region again and again whenever the climate briefly turned green, only to vanish again when the rains failed and the desert reclaimed the landscape. The oldest tools at the site, hefty hand axes typical of a tool-making tradition called Acheulean technology, were the kind associated with archaic hominins like Homo erectus or Homo heidelbergensis, hinting that human relatives had been testing the edges of Arabia for hundreds of thousands of years. Before anatomically modern humans ever existed as a species, later layers showed more refined tools, the kind of carefully prepared stone cores associated with the Middle Paleolithic period, the technological signature of both Homo sapiens and Neanderthals. Arabia, it turned out, hadn't been an empty barrier at all. It had been more like a door that kept swinging open and shut, admitting waves of different human populations each time the climate cooperated, and slamming closed again each time it didn't. What none of that earlier research could offer, though, was proof of exactly who had walked through that door, and precisely when, with the kind of confidence a single bone fragment or scattered stone tool simply can't provide. Stone tools tell you someone was capable of making them, but tools can be picked up, reused, or moved by later people. They don't tell you exactly who held them or when their maker actually stood on that spot. That's precisely what makes footprints such a strange and valuable category of evidence. And it's a point Stewart himself, by then working out of the Max Planck Institute for Chemical Ecology in Germany, made explicitly once the Alathar findings were finally published in the journal Science Advances in September of 2020. Footprints, he explained, aren't like bones or tools that might have accumulated in a single spot over centuries or millennia of intermittent use. A footprint captures a single moment, a matter of hours or at most a few days before the mud dried and hardened, locking in a snapshot of exactly who was standing in exactly that place at exactly that time. A level of temporal precision that almost no other kind of fossil evidence can match. The scale of what the team eventually excavated at Alathar was, frankly, staggering. Once they'd mapped the full extent of the exposed lakebed surface, researchers cataloged 376 distinct footprints and trackways pressed into the ancient sediment. The overwhelming majority belonged to animals that painted a vivid, almost cinematic picture of what this corner of Arabia once looked like. There were 43 tracks left by elephants, a detail that stopped researchers cold because elephants had already gone extinct in the nearby Levant region roughly 400,000 years earlier, meaning that whatever herd passed through Alathar represented one of the last populations of these massive animals surviving anywhere in that part of the world. There were 107 tracks belonging to camels, and dozens more left by wild horses and heavy-set, long-horned wild cattle, animals related to today's water buffalo, all moving across ground that would have looked at the time less like a desert and considerably more like the open savanna of modern East Africa. Alongside all these footprints, the team also recovered 233 separate fossils scattered across the site, including bones from oryx antelope and more elephant remains, along with subtler traces suggesting large carnivores had also been drawn to the same watering hole, stalking the very herds whose tracks now sat frozen in stone. And then there were the 7. Out of those 376 individual footprints, only 7 were confidently identified as belonging not to any animal, but to a human being. 7 prints, out of nearly 400, is a small enough number that the researchers had to be extraordinarily careful before making any claims about who had left them. So they turned to careful comparative analysis, measuring the length, width, depth, and overall shape of each print, and comparing those measurements against reference data drawn from tracks made by both Neanderthals and modern humans in earlier experimental and archaeological studies. The two species, while closely related, actually have subtly different body proportions. Neanderthals tended to be shorter, stockier, and considerably heavier relative to their height, which shows up in the tracks they leave. Homo sapiens tend to have proportionally longer feet, a taller overall stature, and a lighter build. When the Alathar team ran their measurements, the 7 human tracks lined up far more closely with the proportions expected from anatomically modern humans than from Neanderthals, leading the researchers to conclude, cautiously but confidently, that these prints had most likely been left by our own species rather than by our stockier, heavier-boned cousins. Establishing who left the prints was only half the puzzle. The other half was figuring out precisely when. For that, the team turned to a dating method called optically, stimulated luminescence, commonly abbreviated as OSL, a technique that sounds almost like science fiction the first time you hear it explained. Individual grains of quartz sand, it turns out, function a little like tiny, extremely slow-charging batteries. Buried underground and shielded from sunlight, they slowly accumulate energy from the low-level radiation naturally present in surrounding sediment. The moment those grains are exposed to sunlight again, whether by erosion, excavation, or any other disturbance, that stored energy resets to 0. By carefully extracting sand samples from undisturbed layers directly above and below the footprint surface, without ever exposing them to light in the process, and then measuring exactly how much energy had rebuilt inside those quartz grains since they were last exposed to sunlight, researchers could calculate with real statistical confidence precisely how long ago that layer of sediment had been buried. The results placed the Alathar footprints at somewhere between roughly 112,000 and 121,000 years old, squarely within a warm climatic window that geologists call the last interglacial period. That specific window matters enormously to the larger story, because the last interglacial was one of Earth's relatively brief, warm, wet interludes, a period when ice sheets retreated, global rainfall patterns shifted, and, crucially for this story, The monsoon rains that usually stay locked over East Africa and South Asia pushed unusually far north, deep into what is now the Arabian interior. It was, in other words, exactly the kind of climatic window the earlier Green Arabia research had already identified as a moment when the desert briefly transformed into something closer to open grassland. Richard Clark Wilson, one of the study's co-authors from Royal Holloway, University of London, described it plainly at the time, explaining that at certain points in the deep past, the deserts dominating the interior of the Arabian Peninsula gave way to expansive grasslands threaded with permanent freshwater lakes and rivers, conditions dramatically unlike anything visible in the region today. Michael Petraglia, reflecting on why a group of early humans might have specifically been drawn to a spot like Alathar, pointed to the sheer density of resources concentrated there, noting that the presence of large animals such as elephants and hippos, combined with open grassland and substantial standing water, likely made northern Arabia an especially attractive stopover for humans moving between Africa and the wider landmass of Eurasia. This is where the Alathar discovery starts to genuinely rewrite the broader out-of-Africa narrative, rather than simply adding one more. Data point to an already settled picture. For decades, the dominant model held that Homo sapiens made essentially one meaningful exit. From Africa, a single decisive dispersal roughly 60,000 years ago, funneling out along the southern coastline near the mouth of the Red Sea, and that every non-African population alive today descends from that one relatively late migration. Arabia's interior, under that model, simply wasn't part of the story. It was a barrier to route around, not a landscape people actually inhabited, but Alathar's dates, sitting at 112,000 to 121,000 years old, are far too old to fit that single late Southern route narrative. And Alathar wasn't an isolated anomaly either. Just a couple of years before Stewart's team published their findings, a different group working under Petraglia and Hugh Graucut, excavating a separate ancient lake bed deeper in the Nefud called Al-Wusta, had recovered something even more direct than a footprint, an actual fossilized human finger bone, a small intermediate phalanx dated to approximately 85,000 years old. At the time of its publication in 2018, that single finger bone stood as the oldest confirmed Homo sapiens fossil ever found outside of Africa and the immediate Mediterranean rim of the Levant. Further evidence that modern humans hadn't just passed briefly through Arabia on their way somewhere else, but had settled into its interior repeatedly across tens of thousands of years. The picture gets stranger and considerably more interesting once you bring in the evidence from just across the Red Sea and up through the Levant corridor connecting Africa to the rest of Eurasia. At the cave sites of Skul and Kafze in what is now Israel, archaeologists have long known about Homo sapiens remains dated to somewhere between roughly 90,000 and 120,000 years old, fossils that sat for decades as a genuinely confusing anomaly, seemingly far too old to fit any tidy single migration story, and for years dismissed by many researchers as evidence of a small, ultimately unsuccessful population that pushed briefly out of Africa and then simply died out, leaving no lasting genetic trace in any population alive today. Then, in 2018, researchers working at a site called Mislia Cave, also in Israel, announced something even older still, a partial upper jawbone, complete with teeth, belonging to an anatomically modern human, dated using multiple independent methods to somewhere between roughly 177,000 and 194,000 years old. That single jawbone effectively doubled the previously accepted timeline for when Homo sapiens first ventured beyond the African continent, and it did so years before Stewart's team ever excavated the first footprint at Alathar. Taken together, these discoveries, the ancient jawbone at Mislia, the cave fossils at Skul and Kafze, the lone finger bone at Al-Wusta, and now the 7 human footprints frozen into the mud at Alathar, paint a picture that looks nothing like a single dramatic exodus happening once, on one occasion, roughly 60,000 years ago. Instead, the emerging consensus among researchers like Petraglia and Graucut describes something closer to a long, repeating rhythm stretched across hundreds of thousands of years, in which small groups of early humans pushed out of Africa again and again, riding the crest of every brief. Climatic window and rainfall pushed the green corridor of the Sinai and Arabia open, only to retreat, or more likely, simply die out locally, once the rains failed and the desert swallowed the grassland back up. Graucut and his colleagues have described this pattern using the phrase swinging door, a corridor that opened and closed repeatedly over the last several 100,000 years, admitting different waves of hominins during each brief wet interval, then slamming shut again for tens of thousands of years at a stretch, sometimes long enough for an entirely different population. Most notably, Neanderthals expanding south out of a cooling Europe and the Levant, to move into the very same landscape once the modern humans who had been there before them had gone. That handoff pattern is exactly what appears to have happened at Alathar itself. Once the last interglacial's warm, wet conditions faded, and the climate swung back toward the colder, drier state that dominated much of the following tens of thousands of years. The archaeological and fossil record across the wider region shows Neanderthals moving into areas that modern humans had occupied only shortly before. Stewart himself noted this pattern directly, observing that it's really only after the last interglacial ends, with the return of cooler conditions, that the region starts showing solid, unambiguous evidence of Neanderthals moving into the same territory that Homo sapiens had briefly called home. It's a strange, almost poignant image once you sit with it. Two closely related but distinct populations of ancient humans, likely never crossing paths directly at this particular spot, each drawn to the exact same lakeshore purely because it was, for a narrow window of time, one of the only reliable sources of fresh water and game for hundreds of miles in any direction, taking turns occupying the same patch of ground as the climate around them lurched back and forth between green and barren. It's also worth understanding just how dramatically Alathar's ecosystem contrasts with what any modern visitor to the Nefud would encounter today, because the contrast is really the whole engine driving this entire discovery. A visitor standing on that same spot right now would see nothing but rippling red sand stretching to the horizon in every direction, silence broken only by wind, with the nearest reliable water source likely dozens of miles away. But strip away 120,000 years and stand on that same ground during the last interglacial, and the scene shifts entirely. Shallow, sun-warmed water spreads out across a wide, gently sloped basin, its shoreline crowded with vegetation, herds of elephants, animals that had already vanished. For most of the surrounding Levant, for hundreds of thousands of years by that point, wade in to drink and bathe, their massive rounded footprints sinking deep into the soft mud along the water's edge. Camels move in loose groups nearby, alongside wild horses grazing on grass that has no business existing in what modern maps label unambiguously as desert, long-horned wild cattle, animals built. Along the same general lines as today's African buffalo, cluster closer to the water than the more cautious grazers, and somewhere in the grass beyond the shoreline, unseen but very much present given the carnivore traces recovered from the same layer, predators watch and wait for an opportunity. It's a scene that, aside from the specific mix of species involved, would look entirely at home on the plains of modern Kenya or Tanzania, not in the heart of what is now one of the driest, most hostile deserts on the planet. And it was into this scene, on one particular afternoon, that a small group of people, likely a family or a small extended band, rather than any kind of large settlement, walked down to the water's edge, perhaps to drink, perhaps to track the very herds whose footprints now sit fossilized beside their own, and then simply moved on, never imagining that the mud beneath their feet would still be legible more than 1,000 centuries later. There's also a genuinely uncomfortable, humbling wrinkle buried inside this whole story, one that becomes obvious once you compare the fossil and footprint evidence against what modern genetics has to say. If you sequence the DNA of people alive today whose ancestry traces outside of Africa, the genetic signal points overwhelmingly toward a single major dispersal event roughly 50,000 to 60,000 years ago as the source of nearly all non-African ancestry alive on Earth right now, that creates a strange tension with the fossil evidence from places like Mislia, Skul, Kafze, and Alathar, all of which are considerably older than that genetic bottleneck. The most widely accepted explanation researchers have settled on is that these earlier waves of modern humans pushing into the Levant and Arabia, the very people who left the tracks at Alathar, most likely represent populations that simply didn't survive long term, at least not in a way that left a detectable genetic footprint in any population alive today. They were real. They were unmistakably Homo sapiens. They walked, hunted, and drank from the same lake shores that elephants and camels used. And in evolutionary terms, at least as far as anyone can currently tell from the DNA of living people, most of them appear to have been dead ends, populations that pushed out into a temporarily hospitable Arabia, held on for some unknown stretch of generations, and then vanished when the climate turned against them again, leaving behind nothing more than scattered bones, stone tools, and, in one remarkable case, 7 footprints pressed into mud that happened to survive undisturbed for over 100,000 years. It's worth pausing on just how narrow and improbable a window this discovery really represents, because the vast majority of footprints made throughout the entirety of human prehistory simply never survive at all. A footprint pressed into mud is an inherently fragile thing. For it to become a fossil, the mud has to dry quickly enough to harden before rain, wind, or the passing hooves of the next herd of animals erase it. And then it has to be buried gently by fine sediment. Shortly afterward, sealed away from further disturbance and left completely undisturbed for well over 100,000 years until, by pure chance, Wind erosion happens to strip away the overlying layers at precisely the right moment for a passing archaeologist to notice. Every step in that chain has to go right for a footprint like this to survive at all, which is exactly why sites like Alathar and the roughly comparable but far younger footprint sites known from places like Namibia's Koiseb River or Tanzania's Ngersero remain so, rare on a global scale. Stewart and his colleagues were not simply lucky to find a footprint. They were lucky that a single afternoon's walk along a lakeshore, more than 1,000 centuries ago, happened to survive an almost impossibly long chain of geological accidents entirely intact. None of this is to suggest the story is fully closed, and the honest version of events has to leave room for real uncertainty rather than pretending otherwise. 7 footprints is a genuinely small sample size to build a species-level identification on, and while the comparative measurements point toward Homo sapiens rather than Neanderthals with real statistical confidence, the researchers themselves have been careful to frame that conclusion as the most likely explanation, given the available evidence rather than an absolutely certain closed case. It's also worth remembering that footprints, unlike bones, can't be directly radiocarbon dated or genetically sequenced. The age comes entirely from dating the surrounding sediment layers using OSL, an extremely well-established technique, but one that still carries a margin of error, which is exactly why the published age range spans 9,000 years rather than landing on a single precise number. And there remains an open, honestly unresolved question about exactly how many separate dispersal pulses actually happened, how many of them briefly overlapped with each other, or with Neanderthal populations, moving through the same corridor, and how many entirely separate footprint sites. Fossil fragments and stone tool scatters are still sitting out there, undiscovered, buried under Arabian sand dunes that Petraglia's decade of satellite surveys haven't gotten around to checking yet. What is settled, and what makes this discovery matter well beyond a single research paper in a single journal, is the broader shift in how researchers now understand the whole shape of the human journey out of Africa. The old model, one continent emptying its population in a single dramatic wave that swept cleanly across a barren, empty Arabia toward a waiting Eurasia, has given way to something far messier, more human, and honestly more interesting. A landscape that spent hundreds of thousands of years alternating between hostile desert and lush, hippo-filled savanna, repeatedly drawing in small bands of early humans and their close relatives during every brief climatic window, only to strand or extinguish most of them when the rains inevitably failed again. Most of those populations left no genetic trace in anyone alive today. Most of them left no bones we've ever found, no tools we've ever cataloged, nothing beyond perhaps a scatter of stone, flakes weathering slowly out of a dune somewhere still unexamined. What makes the people of Alathar different, what makes this one particular case genuinely remarkable, is that a handful of them happened to walk across the right patch of drying mud on the right afternoon, roughly 120,000 years ago, and that patch of mud happened to survive, buried and protected for well over 1,000 centuries, waiting for a graduate student on a routine survey to notice that the ground beneath his own feet was hiding footprints considerably older than his own species had any right to expect. A single afternoon's walk to a watering hole taken by people who almost certainly had no descendants walking the earth today turned out to be enough to quietly rewrite where, and how many times, our species first stepped beyond the continent that made us.